In this MOOC, we will be using RStudio, which is a programming environment for R. Let's go ahead and open the script for this module in RStudio. The first example we saw in class is concerned with improving a supply chain. We will explore our data set to identify different groups of products that share similarities and that can be treated in a similar way. The first thing that we want to do is to set our working directory to the folder where we have downloaded the SKU datasets. The way you do this in RStudio is that you navigate here to the right folder and then you click on More and Set as Working Directory once you are in the right folder. Next, it's usually a good idea to clean up the memory of your current R session, and you can do that by executing this line. By the way, in order to execute a line, you can highlight it and then press Command Enter on a Mac and Ctrl Enter on a PC. Let's go ahead and do that. We are now ready to move on and load our dataset. Let's call the dataset data, and we'll use the read.table function in order to read the dataset. The read.table function lets us read flat files such as CSV files into R. The first argument of the read.table function is the name of the file that we want to load, and don't forget to put it in quotes. The following argument here is the header argument, which tells R that our original file contains a header, so we set it equal to true. And then we have the sep argument, which tells R the type of separator that are contained in our original file. Let's now run this line in order to load the dataset. Once your data is loaded, the first thing you should always do is to explore your dataset. First, let's use the str function and call it on data. Let's have a look at the output. What the str function tells us is that we have 100 observations in this dataset and 2 variables. What are the variables? The ADS variable, which is short for average daily sales, as you may remember from the lecture, and the CV variable, which is short for coefficient of variation. The str function also tells us the type of variable that we have. Here you can see int, which is R's way of telling us that the variable contains integers only. And here for the CV variable, you can see num, which is short for numeric, and which is R's way, again, to tell us that the variable contains decimal numbers. The next step would be to have more information about our variables, such as their average and some other statistics. And to do so, we can use the summary function, which you can see here. Let's run the line. As you can see, what the summary function does is to give us for each variable the minimum value, the first quartile, the median, the mean, the third quartile, and the maximum value. Since we only have 2 variables, it seems like a good idea to plot our data to see visually if we can already distinguish different groups of products with similar coefficient of variations and average daily sales. To plot data in R, you use the plot function. Your first argument is the coordinates on the vertical axis, so here that is the coefficient of variation, and your second argument is the coordinates on the horizontal axis, which is here the average daily sales. With the main argument, you can add a title to your plot, and similarly with the ylab and the xlab arguments, you can label your variable in order to make your plot much more understandable. Let's now run this line of code. At this point, you should obtain this plot that you can see on the bottom right of my screen. What can you say about this plot? Do you notice different groups of products that are close to one another? If yes, how many? Hopefully, you are able to identify 3 groups of products on the plot. The first group contains the SKUs with a coefficient of variation below 0.2 and average sales between 4 and about 14. As explained during the videos, those are our horses. Our second group contains SKUs with coefficient of variation around 0.35 and about 1, and between 6 and about 14 for the average daily sales. And as you may remember from the lectures, these are our wild balls products. And the third and last group contains SKUs with a coefficient of variation between 0.2 and about 0.7 and an average daily sales between 0 and about 3. These, as you may remember, are the crickets. Let's draw some lines and add some text to our plot in order to make it more explicit. To add a vertical line in R, you can use the AB line function and you pass it two arguments. The first one is V. Since we identified that our first group has coefficient of variation below 0.2, we set V equal to 0.2. And our second argument here is the col argument, which controls the color, so we set it equal to red in quotes. Let's run the line. Now let's add a horizontal line by using the AB line function again, but this time we pass it the H argument because it's a horizontal line, and since we identified our first group, they have average daily sales over 4, let's set it equal to 4, and again we'll set the color to be red. To make our plot more visible, let's add a label to where our first group is. Our first argument is the X value of where we want our text to start. The second is the Y value of where we want our text to start. The third argument is the text that we actually want to insert. And then now you're familiar with the col argument, which sets the color, and that will set here equal to red. Now you can do the same thing for the wild balls and the crickets by running these lines. Now if you try to move your text and lines around a bit, you will find that producing nice visualizations in R can be time consuming and is generally not the most efficient way to produce a business visualization. Using a presentation tool such as Microsoft's PowerPoint or Apple's Keynote and adding pictures and simple one-liners will most often help you convey the points that you're trying to make in a business-oriented manner. Feel free to use any presentation tool that you may be used to and to post the visualizations you build in the firm so that we can all learn from each other's creativity. So by simply plotting our data, we were able to find groups of products that are similar to each other. Let's now try to use hierarchical clustering methods learned in class and see if we can obtain a similar result. First, in order to make sure that we do not alter our original dataset, let's make a copy of it and call it taste data. The way you do this is that you just set taste data equal to data. As we saw in class, in order to make the variables comparable to one another, we need to normalize them. To do so in R, you can use the scale function. Let's use it. We are now ready to compute the distances between our data points, which we will store in D. In R, we can do so by using the dist function, which takes two arguments. The first one is the data set that you want to compute the distances of, and the second one is the method that you want to use in order to compute distances. In this case, we're going to use the Euclidean method. So you set the method argument to Euclidean and do not forget the quotes. Now that we have computed distances, we can finally use the hclust function in order to perform the actual hierarchical clustering. Let's create a new variable called hcword, which will store the result of the call of the hclust function. The hclust function takes two arguments. The first one is the result of our dist function, so D, and the second argument is the clustering method that we are going to use. In this case, we set it equal to word.d, The question of the clustering method that we wanted to select is a technical one, but if you want more information about the hclust function, you can always type $hclust in the console and you obtain documentation on the package, or you can always search for more on the web. Let's now run our hclust function. We are now ready to assign all our observations to our groups, and we can do this using the queue_tree function. It takes two arguments, the output of the hierarchical clustering, HCU_word, and k equal to the number of clusters that we want to create. As we saw in the lectures, we choose to have 3 different clusters. What we're doing in this line is that we're creating a new variable to our original dataset, which was data and not taste data. And to do so, we just write data, $, the name of the new variable, here groups. And here, instead of equal, I've used these 2 characters, but I only did it so that you guys are aware that we can use this instead of equal. What we're doing here is that we're creating a new column to the original dataset, the one that's called data, not taste data. And what this column indicates is for each SKU in which group the SKU is, according to the hclust function. Now that we have our groups, we can finally plot them. The lattice package provides a lot of functions that you should explore to make nicer plots. In order to install a package in R, what you do is that you use the install.packages function and you insert the name of the package in quotes. Let's run it. Then you need to load the package, which you can do using the library function and inserting the name of the package without quotes this time. The plot that I made with the lattice function is the following one. Essentially what it does is that it plots each group in a different color. As you can see, we can find the result that you saw with Professor Glady in the lectures, which is very, very similar to what we already saw by just simply plotting the data on 2 axes. This wraps up our first example, and I will see you in the next video.